Guys, we're starting a new chapter, chapter 4, all about triangles. You'll definitely need to have your calculators. So let's begin. Some of this stuff is vocabulary that you probably haven't seen for many, many years. Let me find my glasses so I can see it. So classifying triangles by angles. So this is by angles. Or highlight that. So you have acute angles, so all three are acute angles. Equal angular means that all three angles are acute and congruent. Obtuse means you have one obtuse angle, which is right there, and then a right triangle. Now you cannot assume anything else unless these markings are here. So that has to have this box. And then these would have to have those markings or the same degree. Now for the sides, put sides here because you have to do both. If they're all the same, they would have these tick marks, and that's an equilateral triangle. Isosceles means two of them are the same. And then scalene means no congruent sides, or I call them scattered. That's how I remember scalene. They're scattered. They're all different. So this is something, and this is something else. So let's classify these by their angles. So we're classifying by angles. So this one would be equal angular. Kind of a weird word. Equal angular, because they're all the same. This one has an obtuse angle here, so this would be an obtuse angle. Okay, down here, again, it's all about what is marked. I want to make sure you can see what I'm looking at on my screen. So they're talking about this big triangle here. It appears that this is not going straight up, so we could say this is obtuse if that's something we're saying. Let's see what it's asking for. So isosceles, scalene. Okay, so we need this one by angles and side. So let's start with triangle JMN. According to the angles, it's very hard to see, but this looks like an obtuse angle. As far as these being equal, that's really tough to say. There is no markings to say this marking, this one would have to have this thing in order for it to be for sure isosceles, but it doesn't. So I'm going to say scalene. Triangle, JKO. So JKO, right here. Okay, again, we don't know anything. We can't tell if that's a right triangle or if these are, nothing's written, so that one's kind of hard to say what type. I'm actually going to put a question mark there because you cannot really tell if that is a straight 90 degrees, because if it doesn't mark it here, then you cannot assume. So I would say that would be, well, you can't even tell if it's an obtuse or if they're all acute angles. As far as the markings, again, I would have to say they're scalene because none of them are marked. Triangle OLN. OLN. Well, now we've got it. This one, they're all marked the same. And I will tell you, if these are all the same, that means their angles are all the same. So that's going to be equal angular, and equilateral. Okay. Next, So what do we know? So it says that find the measures of the sides of the isosceles triangle. So unfortunately these are not marked. I don't know why. I don't know if it's just the printing or why they're not marked, but they should be marked because it's telling us it's an isosceles. This is our hypotenuse. So obviously that cannot be equal to those two. Okay, but here's my base, KL. Okay, so find D. So to find D, we know that these two are equal. So we could just go 12 minus D is equal to 4D minus 13 and solve for D. I'm going to add D to both sides, and I'm going to add 13 to both sides. So he's gone. That becomes 25, and that becomes 5D divided by 5. So D equals 5. If we wanted to substitute our values in here, we said 12 minus 5 is 7. And this would be 4 times 5, which is 20. 20 minus 13 is also 7. So there we go. We solved for D. We could put it in here too. So 7 plus 6 is 13. So there you go. This is the tricky one. And classify each triangle by its sides. Okay. So let's go ahead and plot these points. And you need a straight edge. So 1, 2, 3, 4, 5. 2, 3. 1, 2, 3, 1, 2, 3, 4. Negative 1, 1. Okay, straight edge. Now there's two ways you can do this. You can use your distance formula, which you all know that I'm not a big fan of, to find the distance between this point and this point. And that formula is on the very front cover of your notes. So it's right there. And you would just plug in those 2 points to find the distance. So it doesn't matter which one is x1 or x2, as long as you're consistent. Okay? And it might be good to label those. So, for example, x1, x2, that kind of thing here. I'll just do it. x1, y1, x2, y2. And then do this side, P to L. And find it. But I'm not going to do that because you know I'm not a big fan. I'm going to use the Pythagorean theorem. And to use the Pythagorean theorem, you need right triangles. And there's several ways I can do it. And I'm going to use my outside. So I'm going to make dotted lines to make right triangles, almost like Pac-Man, up and over. So I'm going to go up 1, 2, 3. So I have 3 squared plus 1, 2, 3, 4 squared equals c squared. Calculator time. Three squared plus 4 squared equals 25. So I'm just going to put the square root of 25. Would be my answer, and we all know it's 5. The next one, I'm going to do K to L. So I'm going to dot up and over. 1, 2, 3, 4, 5, 6, 7, and then 2. So 7 squared plus 2 squared equals c squared. 7 squared plus 2 squared, and that would be the square root of 53. Obviously not the same answer. And then we're going to do this one. Dot, 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 dot. So 1, 2, 3, 6 squared plus 4 squared. We can tell all of these are so different, but let's just double check. 6 squared plus 4 squared equals 52. So all of these are different. Therefore, this would be scalene, scattered. Okay? Next one. Okay, so this, it's so hard for me to remember what you know and what you don't know. But I'm going to assume you don't know these things. So the sum of the measures of the angles inside of a triangle, so all of these, this plus this plus this, is always equal to 180 degrees. So measure of angle A plus measure of angle B plus the measure of angle C equals 180 degrees. You'll use this very often. This exterior angle thing will be helpful. So this is equal to angle A plus angle B. So this is the measure of angle 1. The measure of an exterior angle of a triangle is equal to the sum of the measures of the two remote angles. In this case, they were A and B. I like this visual. Next one. The acute angles of a right triangle are, I have no idea what this says. Hold on. The acute angles of a right triangle, are congruent. Sorry. No, they're complementary. Back up. So they're going to equal 180 degrees. Here it is. So A plus B equals 90 degrees. Because this is 90, so 90 plus that 90 between the two equals the 180. There can be at most one right or one obtuse angle in a triangle. If L is a right or an obtuse angle, then J and K must be acute angles. Okay, makes sense? This is right. Both of these would have to be acute. All right, let's look at our little diagram here. The diagram shows the path of the softball in a drill developed by 4 players. Find the measure of each numbered angle. Okay, so first of all, hopefully we can figure this out, just this number 1. How? Because we know all of these together equal 180. So you can say 180 minus 43 minus 74 is going to equal the measure of angle 1. So let's do it. 180 minus 43 minus 74 equals 63. So if I label this as 63, we should automatically know how much 2 is because they are the same. They are vertical angles. Have to know that. So measure of angle 2 would also be 63 because of vertical angles. So again, how do you find out 3? We're going to add these up to equal 180. So all of these equals 180. So I'm going to say 180 minus 79 minus 63. And that's 38. So measure of angle 3 is 38. So 180 minus 63 minus 79 equals. And there you have it. Excuse me. All right, let's try this one. Find the measure of each numbered angle again. So we'll do that again. We know these equal 180. So all 3 of those. So 180 minus 85 minus 45 equals measure of angle 1, which equals 50. So since this one's 50, this one has to be 50. Let's see, where do we want to go next? Okay, this is one of those exterior angles. So these two, let's do the exterior angles. So this guy here, 135, minus one of these angles is going to be the measure of angle 3. So these two equals 135. There's so many different ways you can do this, but just kind of keeping with the minus 50. So that's 85. Could you think of another way to figure this one out? Well, I guess you could do it here. These two form a linear pair. So this plus this equals 180. Or you could say 180 minus these two. So many different ways to figure this out. Okay, so 135 minus 180. So this one's 45. So we did 2, forgot that one because of vertical angles. So the measure of angle 2 was also 50. Measure of angle 3 was 85. Forgot to write that. So now we know measure of angle 4 because of a linear, the straight line here. So linear, or these two are supplementary angles. So what did we say that is 45? Measure of angle 4 is 45 degrees. All we need is angle 5. So angle 5 really could be 75 plus 45. So I'm going to use exterior angles and add 45 plus 75, which is going to give me the measure of angle 5, which is how much? Gosh, there's a lot to this. We really like this. 120. So did we get all these degrees? Were there more? 1, 2, 3, 4, 5. And I can label it if I like. Okay. There you go. It's like a puzzle. Next one. This one looks even more fun. Okay. I'll start with number 1. Can I start with number 1? Maybe I can't always start with number 1. Let's see here. Let's start with number 5. I know this one's 90. So all three of these equals 180. So 180 minus 90 minus 41 equals the measure of angle 5. So how much is that? 180 minus 90 minus 41, 49. 49 degrees. Okay. It's kind of interesting. Since this one's 90, this has to be 90. I'm trying to remember what that's called. So 90 plus 48, well, these two are 90, so let's go measure of angle 3 is the 90 degrees. Right angle something, right angle theorem. Because of the right angle, we know that 90 minus 48 will give us the measure of angle 3. So 42. Okay. This is right. Does that help me? Okay. if I know this is 34 and I want this one, because I need to get these here, this is 90, so 34 minus 90, 90 minus 34, which would have to make this one 56. Okay. These two together are 90. This one's 42 because I'm going to look at this triangle here. Okay, so I'm going to say 42, well, 180 minus this 42 minus these two together, which is 90, which would make angle 4 48. So sometimes you have to solve things that they're not asking for in some sort of way. Okay, let's see. So this one's 48, and we did this because of the right triangle. Okay, so again, a right triangle, and helped us find it, I guess, but that's not how we did it. We did the 180 minus 42 minus the 90 equals the measure of angle 4, which was equal to 48. All right, so this triangle here equals 180. So we know 180 minus 48 minus 56 is going to give us the measure of angle 2. I think I just did this whole thing backwards. 180 minus 48 minus 56 is 76. Okay, so how much is angle 1? 1 is an exterior angle, and if I extend it this way, this would be equal to the 56 plus the 48. Or you could say this is a linear pair, so 180 minus 76. Let's look at both of them and see if they equal. 180 minus 76, I get 104. So linear pair, angle 180 minus 76 equals the measure of angle 1, which I said was 104. Or I can add these two together, or exterior angle, and say 56 plus angle 48, and hopefully it equals the same thing, 56 plus 48. Hallelujah! 104. Yowza. Okay, so what else do we have? Yay, that's it. All right, happy assignment.